So when it comes to thinking about all the possible outcomes of an event, a good way to sort of map that out visually is to use a two-way table. So two-way tables allow us to see all different combinations that can happen when we have two different sort of categories within our data. So just to remind you, sample space means the full list of outcomes. And so what we're seeing in this table here are all the choices or all the preferences from Year 9 students about the type of social media they like to use. And so down this column here, we're comparing boys and girls, and across the top here, we're comparing the different types of social media that they like to use. And you can see some of the data has been filled in for us, some of it is blank, we need to work that out. And so the way we do that is that we have these totals columns, and so this total over here, 25, refers to this row, so all of this row should add up to 25. And when the total is at the bottom, it means that the numbers in that column should add up to 17. So it's a bit like doing a Sudoku. If you like Sudokus, you go ahead and you fill in the blanks. So we know that 12 plus 5 is 17. So to get to 25, there must be 8 left over. So that means there were 8 boys who preferred to use Instagram as their main social media. Now, we know that all up, 50 students were surveyed. That's what this is telling us here. That's our total. And so 25, there must be another 25 missing. And so that tells us that there were 25 boys and 25 girls surveyed in this survey. And so we can use that information now to fill in the missing blank here for how many girls prefer to use TikTok. So if there were 25 girls in total, 5 plus 6 is 11. So 11 girls used either Facebook or Instagram, which must mean that there were 14 girls left over who preferred to use TikTok. And that then allows us to fill in the last piece of the puzzle. So 5 plus 14 is 19. So in total, 19 students preferred to use TikTok, 17 students preferred to use Facebook, and 14 preferred to use Instagram. So that's how a two-way table works. It's a visual way of mapping out all of the data so we can then start to do some probability calculations now that we can see all of the outcomes and the likelihood of that outcome happening. So if, for example, we were to take a student at random, pick a student's name out of the hat, what are the chances that that student prefers to use Facebook over the other social media accounts? Well, there were 17 students who preferred to use Facebook out of a total of 50. So the probability of getting a student, and I'll write that down here, probability of a student preferring Facebook equals 17 over 50. And we just leave our answer like that as a fraction. What is the probability that a girl prefers to use TikTok? So now we've narrowed down our population to just the girls. So now we're dealing with a total of 25. And how many girls prefer to use TikTok? There were 14. So the probability that a girl prefers TikTok, that bracket should be there, is 14 out of 25. And so we can start to make some probability calculations based on the information in this table. All right, let's talk about Venn diagrams. Venn diagrams are really useful in probability when we have situations with words like and, or, and not. And so just to refresh on how Venn diagrams are made, we have this box around the outside, which is called our universal set, and that represents everything in the universe of our problem, everything that relates to this problem. Inside that box, we have two sets of data, or two groups, two categories of data, and they are split up or collected differently depending on the situation. So you can see here, this situation is to do with the coronavirus, and we have one group of countries which have recorded more than 20,000 deaths. That's our Group A, the green group. Over here we've got our blue group, Group B, and that's made up of countries that enforced lockdown measures within 1 month of recording their first case. So they recorded their first case of coronavirus, and then within 1 month they enforced lockdown measures. So the way that we interpret this Venn diagram is that these countries here, the USA, France, UK, Spain and Italy, they've all recorded more than 20,000 deaths from coronavirus. These countries in the blue circle, New Zealand, Brazil, Greece, Netherlands and Italy, they all enforced lockdown measures within 1 month of recording their first case. So Italy's in the middle. These four are not in the green circle, which means that they have not recorded more than 20,000 deaths. But Italy is in both circles, which means that both of these statements are true for Italy. Italy did enforce lockdown measures within 1 month of recording their first case, but they still went on to record more than 20,000 deaths. And so there must be other reasons why that caused them to have such a high death rate. The other thing you might notice is there are two countries down the bottom here which are not in either circle, but they're still within our box, they're still within our world of this problem. And that's Australia and Canada. So Australia has not locked down within 1 month of recording their first case. They have locked down eventually, but not within 1 month. It took them longer than a month to lock down. But they've managed to record less than 20,000 deaths. So they don't fit the criteria for either circle. And that's the same for Canada. So that's how we interpret a Venn diagram. Each of the data or the facts or the statistics within a particular group is there for a reason. It's been collected with other similar stats or data, or maybe there's some rules around if we're dealing with numbers, which numbers can go in that group, and that will be outlined as part of the rules for that Venn diagram. Alright, so now I'd just like to talk about how we use Venn diagrams to calculate probability. So in the first scenario here, we've got this green circle shaded in. And so that means that we're focusing on that green circle. So the question might be, what is the probability that if I pick a country at random from this universal set, that I will get one of those countries in the A group? What's the chances if I pick a country at random, I'll pick a country which has recorded more than 20,000 deaths? Well, to solve that problem, we need to first of all count how many countries we have within that green circle. How many countries are we dealing with that have recorded more than 20,000 deaths? And there's 1, 2, 3, 4, 5. So there's 5 countries in that green circle. But in total, we have 11 countries in our universal set. So that's 5 out of 11. Imagine you're drawing these countries out of a hat. You've got 5 out of 11 chances of drawing a country out which has recorded more than 20,000 deaths. So we make that calculation by comparing the set we're dealing with to the universal set. So how many countries or how many numbers or how many stats in that particular group we're looking at compared to how many are in the total group. So looking at this one now, you can see everything is shaded around the A, but not inside. So in this case, we want to know the probability, if we pick a country at random, what are the chances that we select a country that is not in the A group? And the way that we represent that with maths is we use that little dash, and that means not A. So it means what is the probability of not selecting an A country? And so to do that, we need to count how many countries are outside our A group. So there's 1, 2, 3, 4 in our B group, but there's also 2 outside here which are not in the A group either. And because we're concerned with anything that's outside the A group, we're going to include all of those. So there are 6 countries outside the A group, outside of 11 countries in total within our universal set. And so the probability of not getting an A country is 6 out of 11. All right, 2 slightly different scenarios here. In the first one, we want to know what is the probability of selecting a country in A or B. And as you can see from the shading, it doesn't matter if it comes from A, it doesn't matter if it comes from B, and it doesn't matter if it comes from the middle section where they are both true. Those statements are both true. So in this scenario, we need to first of all work out how many countries are contained within both of those circles, and there's 9. And then we divide that by how many countries we have within our universal set, which is 11. So if we select a country at random from our universal set, what is the probability that that country comes from A or B? What is the probability that that country either has recorded more than 20,000 deaths or has locked down their country within 1 month of recording their first case, or has both of those things true? And the answer is the probability is 9 out of 11. The last scenario here, you can see we just have the middle section shaded. So in this scenario, we want to know what is the probability that if we pick a country at random, it will have recorded more than 20,000 deaths, and it also locked down within 1 month of recording its first death. So this is the probability for A and B. If we select a country at random, what's the probability that both of those things are true? And there's only one country that meets both of those criteria, and there are 11 countries still in our universal set. So we get a probability of 1 out of 11. And so that's how we use Venn diagrams to make probability calculations. It helps us to visually sort the data, and then we're able to use that visual sorting to start making calculations about how likely something is to occur. The last type of event I want to talk to you about are called mutually exclusive events. These are events where we have 2 possible outcomes, but we can only choose one or the other, not both. So to give you an example, I'm going to use a Venn diagram to help me explain it. You come to an intersection in your car and you can turn left or you can turn right, but you can't do both. And so that's represented here in this Venn diagram. You can see turning right is one outcome, turning left is another outcome, but there's no overlap. There's no space where both of those things can be true at the same time. So you have to turn right or you have to turn left, but you can't do both. All right, here's another one for you. So you're flipping a coin and you can either get a head or a tail, but you can't get both. And so again, that's represented by these circles being separated. There's no space where they're both true at the same time. When it comes to probability, we know that the chance of getting a head is 1 out of 2. There's 2 outcomes and the heads is one of those outcomes. Tails is also half, 1 out of 2. So what is the probability of getting a head or a tail? Well, we add those probabilities together. So the probability of head or tail equals the probability of getting a head plus the probability of getting a tail. Substituting half and half, and we get an answer of 1, which makes sense. Because if you're flipping a coin, you have to get a head or a tail, and getting an answer of 1 represents something that's certain, doesn't it? When you flip a coin, you're certain to either get a head or a tail.